I hope that most of you have gone through the syllabus. First two chapters are widely covered by us, and as per our philosophy, we are supposed to widely cover entire contents once, and then we go minutely to those aspects which need some more level of understanding. Some problem? More level of understanding. So with that, we now move to third chapter, that is two-port networks. As regards to this chapter, I would like to have opening remark that it's a very simple chapter in the sense that we are not going to learn any kind of new theme as such here, but we are just trying to represent something in alternative form. Thevenin's theorem we have studied, Norton's theorem we have studied. Thevenin's and Norton's theorem, what do they do is when one electrical circuit is there, if you take any 2 points, then Thevenin's theorem gives us a new sight, new vision with which we look towards the circuit in a particular way. Whatever may be the circuit, we can look to the circuit as if it is comprised of one Thevenin source and one Thevenin's resistance. Whatever big circuit it may be, a very big diagram, then you can have 2 points, 2 studs coming out, you can see, and if you look from these 2 points, the Thevenin has provided us a way that I can look that a Thevenin source and a Thevenin's resistance are connected between these 2 points. So, whether I am learning a new thing there, no, just circuit is otherwise functioning. I am trying to put the circuit functioning. The question if I want to connect something to these 2 points further, what will happen? That will depend upon the entire circuit and what I connect here. So it will be a very complex analysis. In order to simplify analysis, Thevenin's theorem provides me a way that I look, means if I am looking from 2 points, so this is called a one port, means this entire circuit is there, from that 2 points are coming, and I consider myself looking through these 2 points. So it is a theorem connected with one port. 2 points comprise one port, and then I look towards entire thing in this manner, VTH and RTH. So it's a Thevenin's theorem. Similarly, many occasions we come across various systems for which we connect some input and system delivers some output. System is there, to that we connect some input and system delivers some output. Output depends upon what the system is, what the input is. What the system is, what the input is. If I want to comment on what the system is, in that situation I need some systematic way in which I can look towards the system as a whole. Usually in input and output, one terminal is common. With respect to that, I apply voltage at one point, I get voltage at the other point. So usually my system is like this. A common point which I say as a reference. Right now I am not coming to that detailed discussion of common, ground, earth and all those things. But everybody understands a common point. What I see, it need not be shown like this also. So it's a common point. Then I connect something, they may be like this, they may be like this, they may be like this, it may be like this, it may be like this, whatever it may be. So I connect, this is one port and this is the other port and this is the system. Is it clear? One port, other port, and this is the system. So these are 1 1 dash and 2 2 dash. It is common, but that we are not. It's not an essential requirement as such, but usually it is common. If it is common, then you may say why 1 dash and 2 dash is different. So usually it is common. Right now we do not give stress on that. Therefore, what we can see, whenever I was analyzing for Thevenin's theorem, I was looking from one pole to the system. Now it requires to look towards the system from 2 poles. Therefore, it is called a 2-port network. Means in a system, if I get access to 4 points, then 4 points I can define like this: 1 1 dash, 2 2 dash, 1 1 dash, 2 2 dash. Then when these are 4 points, what the thing to be talked about? Thing to be talked about is voltage V1, voltage of 1 dash is V1, and current I1. So from a particular port, voltage of the port and current flow. It is presumed to be common, so that is not a major issue. It is presumed to be common. Then similarly, V2 and I2. So I look at 2 terminals, and that is common point we can say. V1, V2, I1, I2. Then when it is V1, V2, I1, I2, I try to codify the functioning of this system. I try to codify. I may have a very complex circuit inside. But whatever may be the size of the circuit, Thevenin has provided us a way with which I can look only 2 values for the circuit. Are you getting me? What Thevenin has provided me? The magic way. However complex circuit may be, I look it from 2 points and I only look with 2 parameters. One is VTH and one is RTH. So for 1-port network, I can entirely describe. Means there may be 2 different circuits may have same Thevenin's parameters. Agreeable or not? 2 different circuits may have same Thevenin's parameter. So what does it mean? I give you a very simple example. Circuits are different, but from these 2 points, they behave. Through these 2 points, they behave in similar way. Means 2 different persons may be there, but for me, they behave in the same way. They are 2 different persons, but as regards to the points through which I access them, they behave similarly. One may be very good, one may be otherwise very bad. But for me, both are same, because I access them through 2 particular points. So 2 different systems, completely different, 2 points drawn, and system 1, system 2. But if we look from these 2 points for the system 1, these 2 points for the system 2, look of system 1 from these 2 points is same as look of system 2 from those 2 points. So those are equivalent. Yes?
Sorry for disturbing. Good morning, friends.
So Thevenin's theorem provided us a way of looking. Thevenin's theorem has provided us a way of looking toward a system from 2 points, whereas this 2-port network parameterization provides us that a system we have, whatever may be the system, there are 2 points, there are 2 other points. If I connect something here, if I connect some additional input there, what I will get from these 2 points. If I connect some additional input here, what I will get from these 2 points. Is it clear? Whatever may be the system, you can take 4 points, bring them out. A big system it may be. Bring 2 studs like this coming out from here. Connect a voltmeter here, apply some input there. So 2 points are used as input, 2 are used as output. Or what will be the effect if I make some changes on this? If I apply something on this side, what it will emerge at? Or vice versa. If I apply something on this side, what it will emerge as? So this 2-port network parameterization provides us a very simple view of system look. That is this, how the system will behave relatively with these 2 ports can be entirely described by 4 parameters. With only 4 values we can completely describe the working of the system as regards to interrelationship of 2 ports with one another. That is called as 2-port network parameters. Those are means V1, I1, V2, I2. V1, I1, V2, I2. Then we have, you are aware of the matrix relationship. So since there are 2 parameters, so total there are 4 parameters. So as there are 4 parameters, straight away we would be having 2 equations. We will be having 2 equations with 2 unknowns in each equation. So I can simply say like this. Say for example, V1 have you studied somewhere? Where? Huh? There are total 4. Total 4 are there. So any 2 you can put on this side, any 2 you can put on the other side. Any 2 you can put on one side, any 2 you can put on other side. How many combinations would be there? Any 2 and order again.
4.
How many combinations would be there?
4.
So how many combinations? 4C. Total 4. There are 4 positions. 4P4. Right? Or 4C4. Think of how many it would be, but let us start with 1 at least. So V1 and V2, I1 and I2. And since it is V and I on the other side, the thing in the matrix is Z, impedance. Since V is equal to something Z into I. So it is called as Z11, Z12, Z21. In 2-port network, we are not learning any new thing. First, we can go for Z parameters. For DC circuit, it will be R parameters directly. Z parameters provide us a way which provides me 4 impedance values which describe the system functioning fully. So the equations are V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. How to find these 4 values? How to find these 4 values?
Z11 is equal to V1 upon I1.
In one equation, you can make one value 0. Keep one open circuit. Keep one open circuit, and you will be getting. So let us now. There are some ways where we better understand by there 2 approaches. First definition and then computation. First definition, then computation. This is classical way, but there may be some problem because definition is abstract and we don't mean something. There is reverse way, computation and definition. So compute compute Z parameters for the given circuit. Let us, I hope whatever I wanted to describe which is essential, I will describe. So with this information for the given circuit, compute Z parameters. Let us see how effectively we can function. So you can put a pause. If this, we are now looking in the circuit when I have two ports, there are four values. Four values must have some relationship because those are the circuit. So four values can be interconnected with four variables. Four values, two on one side, two on the other side, so there will be 2 by 2 square matrix, so four parameters. And I can have freedom to express any two on one side, any two on the other side. So I have chosen 3 ways. Out of 16 possible ways, I have chosen 3 ways. So these are Z parameters, Y parameters, H parameters. Any complaint of non-understanding cannot be entertained because there is nothing to be understood. Are you getting me? There is nothing to be understood at all. In a circuit, there are 4 values. V1, V2, I1, I2. You can connect V1, you can connect V2, both you can connect, I1s will vary. One you can connect, other you can short, other you can keep open. You do not connect, if you do not connect anything, what will happen? Then both I's will be 0 in any case. What V's would be if they, now here V's will also be 0 because there is no source inside. There can be source also inside. There can be another source inside also. Whatever may be the circuit, from it is just like, say, if there may be some advanced biomedical equipment. So electrodes are there. So what a child will do, electrodes are there, one displays there. So a child will, if you give it to child, he will take your body and put the electrodes at 2 points and see what is the reading. Similarly, now we have 4 electrodes and you can see just what we can say, entire circuit you can look as a punching bag. Entire circuit you can look as a punching bag, and there are 4, what we can say, electrodes like insertions, 4 inserting rods on 1 dash, 2 dash. Have the bag, put it at 4 places, 1 dash, 2 dash. So you may connect something here, you may connect something here, you may connect both, anything at both places, you may connect nothing anywhere. Whatever is inside, I don't know. Between 1 dash, there will be I1, V1 I1, V2 I2. So we want relationship, that's all. There is no question of understanding. Whenever we have a circuit, we have 4 points. As there are 4 points, there will be voltage across it, there will be some current flowing through it. The same current will come out because it is whatever I am connecting from here, it should come out. On the other side, same thing should be there. So therefore, I will not show reverse coming. So that is not needed. So 2 points, voltage across them, current supplied by them. It means I look in this way. So I simultaneously look like this. I simultaneously look from these 2 ports. And so when I look from these 2 ports, only 4 parameters, voltage, current, that's all. So 4 parameters, so 4 values, 2, 2. So 2 by 2 matrix, 4 parameters. V1, I1, V2, I2. I can write them, their relationship in 16 possible ways. I can write it in 16 possible ways. Of them, 8 would be meaningful because when I write one, I can just, by reversing the order, means out of 16, 8 are duplicate. 8 are duplicate, right? Just by swapping over. But except that 8 are meaningful. So I can write in different ways. This is one way in which I have written. So we have to find. Stop. Pause. It's high school algebra. Everybody has to find all the values. How can you not find? I2. You can continue. Start. V1 is equal to Z11 I1 plus Z12 I2. If you want to find Z11, what you will do? You will, it's an equation in which we have two variables. When we, or what we can say two parameters. When we want to find one parameter, I should nullify the effect of the other. How can I do that? If I put I2 equal to 0, if I2 is equal to 0, then Z11 is the ratio of V1 upon I1. So what I will do? I will keep this open. I will connect some voltage source here. I will connect some voltage source here. Right? And I will find the current and V1 upon I1. I will have a universal 1 volt source. There is a very simple way to look at. I have 1 volt ideal voltage source. So that is 1. So what I will do, how I will find Z11? To find Z11, I will come here with my magic source. I will come here with my magic source. I will connect it here. It's 1 volt. It's of 1 volt. Right? So what is V1? 1. I will compute I1 and I will keep this open. So now Z11 is the ratio of V1 upon I1. V1 is 1. So I1 I will compute. What is I1 then? 1 by 15. So what is Z11? 15. So I hope with this now everybody has to compute. So you compute, you can take magic source, you can take magic voltage source, magic current source and compute all the possible parameters. For both of these circuits you have to compute all 3 parameters. Z11, Z12, Z21, Z22, similarly Y, similarly H. Pause. Start. Okay. So magic source, connection of magic source was a requirement. Is it? No, it was not a requirement. Because the circuit is behaving on its own, magic source is not needed. Magic source was one very brute force way to compute the things. But he has come up with a systematic way. That using Kirchhoff's laws, write down the equations. Using Kirchhoff's laws, write down 2 equations and rearrange those 2 equations in the way you like. So for this, it would be like this. For this, it would be like this. So for this, V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. So depending upon what 2 you keep here, what 2 you keep here, there would be different ways of writing the equations. There would be a set of 2 equations and each equation will contain 2 parameters. There are, it's a one column matrix with 2 rows, other column matrix with 2 rows. So this is 2 by 2 square matrix. The way in which you rewrite this, the values will change. So in every way there will be 2 equations and in each of these equations there will be 2 unknowns or 2 parameters you found out. Then by using Kirchhoff's basic laws, you can construct 2 equations very easily and have your conventional manipulations of each other, multiplying by from these 2 equations you can construct, once 2 equations are given, by multiplying 1 with 3 and adding it with 4, you get one more equation. So you derive equations in such a way that any 2 can be the full equations unless you cancel out each other. Right? So you will always get 2 equations in different forms. And if my equation matches with the form I have, I get the parameters directly. So let us adopt his way for finding out Z parameters. So Z parameters, for finding out Z parameters, I should use basic Kirchhoff's laws. I will get two equations. How? One loop, other loop. Is it? Are you getting me? Presume if you connect some voltage source here, or source that is not also needed, simply Kirchhoff's law. This is V1, so this must be, this V1 must be equal to this voltage plus this voltage. V2 must be equal to this voltage plus this voltage. This is I1, this is I2, so this must be I1 plus I2. So this is I1, so this is I2, so this must be I1 plus I2. Correct? No problem? So Kirchhoff's node law we applied. Now we apply Kirchhoff's mesh law for first loop. That is V1 is equal to 10 I1 plus 5 into bracket I1 plus I2, and V2 is equal to 20 I2 plus 5 into bracket I1 plus I2. Now that we can just rearrange. So V1 is equal to 15 I1 plus 5 I2, and V2 is equal to 5 I1 plus 25 I2, right? 5 I1 plus 25 I2. So I got the same thing. Position V1 V2, I1 I2, I1 I2, same. Means Z1 is 15, Z12 is 5, Z21 is 5, Z22 is 21. So it's 25. Z22 is 25. So I got same values by different ways. By different ways you must have got same values. Correct? So using this you can compute all possible things. Is it clear? So there is one node. This is simple. For this circuit there is one node. So we will have one equation and two loops. So two equations. That's all. So for this, what will you do? For this, I1, I2. I1, I2 we have. Then you may be required. For this, what will you do? Can you do it the same way? How?
I1, I2 and then I from coming through 21.
What is that? What?
I current.
You will assume one more. So I1, I2, we need to assume one more, but that we do not want to keep in final equations. Are you getting me? That we don't want to keep it in final equations. So it requires creation of one variable and its abolishing. Here, creation was not required. Very simple system here. There, you need to create and abolish. So let us next question is DSA, I think. So make a pause. Let us see whether I have a pause. In second example, we can go for delta to star conversion, so that it will become like first example, right? But what I see is the efforts required to convert delta to star, and then again original efforts. Maybe we can solve by alternative ways, but that is also a correct approach. Means it's not a wrong approach. Both may be correct. What is appropriate depends upon your perception. So now let us find out Z parameters for this circuit. So these two equations we must always remain. Means we want to express V1 and V2 in terms of I1 and I2. So now I redraw again. just one simple modification. Instead of taking this way, because why you will understand, we are anyway assuming, so there is no point in assuming current in this way, and there is no point in assuming current in this way. What that will help in the middle loop writing, you can assume whatever you like, but if you assume in a convenient way, then usually it is simple to write. Both are correct approaches. In one I get to the answer easily, in the other it takes some time to come. So this is the loop. So now by writing what this would be then? This is I, this is I1. So what would be this? I minus I1, right? I minus I1. What would be this? I plus I1. Okay? And then write it for this loop, there is no source. So 10 into bracket I minus I1 plus 20 into bracket I plus 30 into bracket I plus I2 must be equal to 0. Now this will allow us to write I in terms of I1 and I2. I in terms of I1 and I2. Right? I in terms of I1 and I2. So we can write that and then have this loop, and compute set parameters. Pause and compute.